Hello and welcome to the TS Master tutorial series, a practical guide for automotive communication. My name is Ali Khairi, an ADAS control engineer here at Software Motion Company. Whether you are an engineer just getting started working with vehicle communication or someone who are interested in test and simulation tools for in-vehicle communication, this course is designed for you to gain a clear and hands-on guide. Well, now that we have an introduction, let's talk about the contents of this tutorial series. We will start with an introduction where you get familiar with installation requirement and the software environment and overall workflow. There we are going to talk about interface steps and you can organize them effectively in order to be more convenient and easy to use. Then we are going to talk about CAN-FT trace, where you can capture, filter messages over the CAN, whether you send or receive the signals. Then we are going to talk about CAN-FT transmit windows, where you can manually define a signal and send it over the CAN, a essential key for testing ECUs. And then we are going to talk about CAN statistics, when you can check error frames, bus load, and overall you can check the communication health. Then we talk about visualization tools in TS Master, for example, graphics, gauge, and later we are going to talk about panel. It depends on the way you are going to monitor the signals. It depends on what you want to see. For example, in graphics you can see the signal over the time. In gauge you can see the signal dashboard style, and panel you can see live data capturing. All of these features are important and useful in order to analyze and detect the issue. Next we talk about CAN database. You can import a DBC file or BLF file. You can edit, import it and edit it, and you can use signal level data, which is very important. Once we get familiar and comfortable with all of these basic, we move on to the more advanced feature, for example, virtual hardware configuration, bus login and playback in order to record and replay the real data over the CAN. Also, we are going to talk about CAN RBC, which stands for Remaining Bus Simulation. Very important feature to test ECUs and its response. And as we move on, we talk about C-script editor, panel, and how you learn how to build the test system. And last but not least, we are going to talk about measured and setup and XCP, a very important feature that allows you to accuse and calibrate data over the CAN. Before diving into technical content, so let's talk about who this tutorial series is for. Obviously, automotive network engineering enthusiasts or overall anybody that interested in vehicle communication can use it specifically. Also, ECU developer, test engineer, and diagnostic specialist, or anyone that his works involve testing and simulation vehicle communication can use this tutorial trailer for automotive simulation network analysis learner. It's very important because it can be used for both research and industry application, and anyone who wants to learn both for those in purposes can use this series. Well, let's look at the hardware overview. As you can see, the Tucson TS Master can be seen here. This device is equipped with multiple CAN-FT channels, which makes it has a robust communication, which is very important to have in the communication to analyze vehicle communication. Also, it supports high speed data logging, which is very important in order to don't miss critical events over the CAN. And last, it's ideal for a wide range of development environments that make it perfect for both research and industry application. Well, the question is, why learn TS Master? You can see the V model here, a standard framework for automotive development. At the left side of this V model, you can see the refinements phase. From requirement, we go down to reach implementation. After implementation, we can go forward, you climb up to maintenance. This phase is validation and verification. TS Master can be used in the right side of this V model when you can check and do different tests. For example, SEAL or HIL, that respectively both stands for software in the loop and hardware in the loop. And overall, in short, I can say that TS Master bridge between design and verification. Let's talk about the key features of TS Master. You can instantly see what's happening in the TS Master. This feature is very important for analysis and simulation. You can also simulate ECUs, one or more than one ECUs, and test behavior on the different scenarios. You can define different scenarios and check the response of each ECU over the CAN. You can visualize signals via graphics, gauges, and statics, as I already mentioned. The way you want you can see the signals. Also, you can access and manipulate network databases like DBC and LDF file. It means that how meaningfully can raw data from the vehicle can be defined. In DBC file and LDF file, you can see the unit, maximum, minimum, and any of property of the specific signal, and you can edit it, and you can see what that raw data means. You can configure your workspace selector to fit your test setup, which is very important to be more convenient to work with. And maybe the most important feature, XCPLC, is a calibration diagnostic, which is very important for debugging and for testing that your module that you're developing with automotive communication. Well, this was the first session of our series. Thank you so much for your time, and if you have any question, you can contact me with this email ID.